Okay, good all. My name is Liu Cheng Liu, the student from UTHM in Industrial Chemistry course, year 1 student. So today I will present about the instrument I choose, which is the GC, gas chromatography, in petroleum industry. So what is chromatography? Chromatography is the one of the most widely used uh, analytical and speculation technique in process and manufacturing industry. The name of the chromatography is derived from Greek for color writing and was first delivered yearly in the 20th century in Russia by Mikhail to spread plant treatment. Nowadays, the chromatography is a multi-million dollar industry and is found in most analytical development and quality laboratories around the world. The basic principle behind the chromatography are simple, which is a sample is carried across the stationary phase by mobile phase, which cause the sample to split into each individual component that are then seen by the detector. And the chromatography can offer a great deal to the petroleum industry. So let's take a look for in take a look a few signs. When it comes to the petroleum industry, the GC gas chromatography is king. Why is king? Because this is due to the fact that gas chromatography is the best system for the analysis the volatiles and many of the compound in the petroleum industry are easy to convert to the gas. So GC gas chromatography is used to analyze both finishing product and in process simple. Yeah. The GC gas chromatography system are simple really. They compress an injection system to add the sample, a chromatography column to unload the component to separate, and a detector to send sensor when a component is exit the system. And it is a range of the detector available to the petroleum industry that make gas chromatography feasible. The detector that's used in gas chromatography in petroleum industry is commonly used such as FID, flame ionization detector, uh, to sensor the light hydrocarbon in the refinery stream. The next one is the TCD, thermal uh, conductivity detector, to analyze the inorganic gas in ambient and workspace environment. So third is the PID, photo ionization detector. Just use the UV to analyze the BTX, which is the mixture of the benzene, toluene, and some ethylene, and also have also sensor the unsaturated and the aromatic compound. So at the last is the flame photometry detector used to uh, analyze the sulfur compound in the stream and the oil residue. The one common product of the petroleum industry, which is a gasoline. The gasoline is a fuel made from the crude oil and other petroleum liquid. Gasoline is mainly used in the engine fuel in the vehicle. So the GC, the gas chromatography, or used to analyze the compound in the gasoline. So the compound in gasoline that we have is isobutane, butane, and isopentane, pentane, 2,2-dimethylbutane, 2,3-double butane, and so on in the paragraph. So the most important compound that we want to analyze is the ethanol. The ethanol that is blended into the gasoline to reduce the pollution and boost the octane rating can reduce a car fuel economy because the ethanol fuel it can lower the carbon emission, and the gasoline with a high ethanol content can also decrease the core fuel line and severely damage the car engine if the ethanol level is exceed the nominal 10% level and approach the 50%. So that is important for the GC to analyze the ethanol in the gasoline. So here is a example result for the gasoline and use the gas chromatography with the TCN, which is the thermal conductivity detector. So for the regular 87, the resolution for one peak is represent for the one compound. So in here we can get the ethanol, the toluene, the extreme, the decant, and also the hexane. So uh, from the graph to the uh, uh, left to the right is light compound to the heavy compound. For the example, the hexane is at the left side, so the hexane is a light compound, and at the left side, as we can see, have a decant is a heavy compound. So here is a Shell regular 87 gasoline, and also we can see the clear peak for the ethanol, and beside that, I also get the toluene, ester, and the nickel. Then for the next gasoline, EXO Premium 97, 83, right? And in here we also get the shape peak, uh, the ethanol, and also the other heavy compound, the aromatic compound, toluene and ester. I also got the decant. So the last is the stick regular at 87, and also get the peak for the ethanol, and also the compound toluene, ester, decant, or and the hexane. So here is the ethanol label for the for gasoline. So in here, the for gasoline is the can be used because the percentage for the ethanol label is not is under 10%. So for the gas chromatography, it's just no analyze the gasoline only. It also can analyze the another product or the sample from the petroleum industry, uh, such as the diesel, the fuel, the LPG, the liquefied petroleum gas, and kerosene, and so on. So the important thing to analyze the compound is one to identify the compound and identify the properties of the compound, which is melting point and the boiling point of the compound, and then to want to identify the polarity. If the compound is polar, if you state at the graph at the left side. If a non-polar compound, if you state the peak at the right side. So then also want to identify the aromaticity of the compound and identify the functional group of the compound. See if functional see if the aromat carboxylic acid group or the alcohol group, and also want to identify the size of the compound. If the size is small, it will have a peak at the left side of the group, and the diffusion for the compound also higher. And if the size is big, it will start the peak at the right side. So in conclusion, the chromatography is important in petroleum industry because most of the sample of the product is volatile. So this chromatography is important for the petroleum industry for the routine check because want to always check the compound in the product or the sample. So the GC gas chromatography is a king for the petroleum industry. So that's all uh, from me. So thank you.